For you, this lesson is an introductory lesson to vector math in one dimension. This should feel like review for you. The way that you should use these notes, I think, is to, when you see a new screen up, pause, write it down, and then listen to my explanation, or listen to my explanation, then pause and write it down. Maybe try not to do them both at the same time, because I'll end up going too fast for you to keep up, and you'll miss out on the explanation, which I think is the most important part. So first of all, one dimension means one motion is only either north-south, east-west, or up-down. In other words, there's no angle in the direction, and you'll see what I mean here. A one-dimensional example would be if an object is moving 2 meters north, so it goes say it starts right here, moves 2 meters north, then turns around and ends up going 4 meters south. That's a one-dimensional problem, and I know that because the displacement is, in this case, vertical, but it's either just horizontal or just vertical. However, a 2D example might be if an object is traveling 2 meters north and then 4 meters east. I'd call that 2D because, again, if I said I'm starting right here, and then I go 2 meters north and then 4 meters east, here's my displacement vector, and the displacement's going to be on an angle, right? It's not just east or just north. So that's just an explanation of what it is, and we'll just do a couple quick examples with one-dimensional vector math. Again, pause if you need to. Okay, so here's our example. Why don't you write down the question? I expect you to stop, write down the question, pause the tape, and I'll go to the solution in a moment. Okay, so Ferd walks 10 meters north and then turns around and walks 15 meters south, his overall displacement. So basically from where he started to where he finished. So first of all, you need to decide what's positive. I'm going to call north positive. So then really I'm just adding. I'm adding these two vectors. This is his motion. So positive 10 meters because it's north. Then I minus 15 because that's south, so it's the negative direction. So his overall displacement is, you could call it minus 5 meters. If you took the time to write down north positive, then I can tell by reading the answer that minus 5, it's implied that it's south. But if you write 5 meters south, either one of those are perfectly fine. I realize this is a very easy example, but it is how you do it. If you're adding vectors, this in doing displacement is just adding vectors. It's saying, okay, first he moves here, and then he moves here, right? You know, and I'm really adding those two vectors is what I'm doing, even though it's a very simple example. Vector subtraction, and you might ask, why would you do a vector subtraction? And that's mostly, there's a few different reasons, as you'll see when we get into more kinematic problems, but the easiest example is acceleration, because acceleration is based on a change in velocity, and change in velocity is v2 minus v1, and those are both vectors. So what we're getting to is doing acceleration in 2D. But in one-dimensional example is if I say he's initially driving, excuse me, 20 meters per second east, and then he turns around and ends up moving 10 meters per second west, what's the change? And so if I called east positive, and again, it doesn't matter what you call positive, you could call west positive and do this solution, but I'm going to call east positive, and that means that my V2 is positive negative 10 meters, brain fart there. My V2, because it's west, has got to be negative, right? And so it's negative 10, and then I'm subtracting 20 meters east. So east is the positive, so that just goes minus 10. So V2 minus V1 is minus 30. And just to think about it as far as, you know, what makes sense. You know, if he's starting going 20 meters per second east, he ends up going 10 meters per second. What's the change? Well, it changes a full 30 meters per second in the west direction. It kind of makes it's more logical without even doing the math, but you have to understand the idea of applying a positive or negative sign, calling something positive, and doing the calculation. Okay, so that's it for 1D vector addition and subtraction.